Arrays are nice when we want to be able to store things together that are related and kind of keep them in a list-like structure. However, we can't necessarily represent everything with the arrays that we've done so far. In order to fix this, let's talk about multi-dimensional arrays. Say you wanted to play something like Connect 4. The board for that is kind of like a rectangle, right? Looks something like this. I'm just going to make it look like a table. And when players drop pieces, they go to the bottom and they have a position to be stored in. So maybe the first player plays red, and then the second player plays yellow, and then red plays here, and then yellow plays here, and so on and so forth, right? We kind of fill up a grid as we play something like this, right? What a multi-dimensional array allows us to do is to create a grid exactly like this. So we could do something like play Connect 4, or we could do something else that is grid-like. For instance, matrices would be a common example of something that we could use these for. Let's just say 8, 10, 9, something like that. If we need to be able to represent things that take up multiple dimensions, so here this is like a series of rows, right? And so is this one. Then the way we can do that is with a multidimensional array. Now the way that we've been declaring arrays beforehand was just int r and then the square braces and then however big we wanted to make the array, right? So let's just say I did this. Then I'm going to draw this vertically, even though we've been doing it horizontally for the most part. This would create an array of size 4. So just basically make kind of like a line containing 4 things, and we'd be able to put 4 things in there, right? 0, 1, 2, and 3. Now the way we do multi-dimensional arrays is to simply just keep adding more layers on top of this. This first layer is going to represent how many rows we have, and then if I was to make a 2D array, which I'm just going to do here, and make this by 3, then this is just going to basically add 3 things per row. So this will make a 4 by 3 array. Right? And so this has 0, 1, and 2. Still indexed the same way, we gotta start counting at 0. But the first one traditionally represents how many rows there are, and the second one is how many columns there are. So if I was to access something, then I could do something like R, and then green would be the first one here, so something like 1. Let's just say I go to the position 1, 2, and I put the number 4 there. Then I'm going to go first in the rows, so I'm going to go to row 1, and then column 2, and that's where the 4 goes. So this would be it here. This will allow us to keep more things in kind of like a square shape, if you want to think of it that way, or a rectangular shape. And this kind of opens up a lot of things for us to be able to do. Like I said earlier, we have access to something like Connect 4, something that's 2D like that, or we can do something like matrix. So I could do matrix multiplication or matrix addition and add a library that does all that kind of stuff using a 2D array. I also have the ability to represent your screen, right? Because your screen has X and Y coordinates and it's kind of flat, right? Your monitor is a flat thing, and so what your monitor really is, it's just kind of a grid where the squares are very, very tiny. They're called pixels. And I could, let's just say, access them and draw different colors in them. So I could say, 0, 0 is black, and then 1, 1 is red, and then 1, 0 is red, and draw a whole picture in that kind of way. So multidimensional arrays open up a whole lot of possibilities for what we're able to do. And really, as far as declaring them, it is as simple as just putting more braces that specify where things go. If we go back to one of these examples, let's just say the array example here with matrix, then I think we could access that. So here I'm going to create a new page. Let's just go through how I might set up a matrix like this. I'm just going to put these in order. The way we want to access arrays when we're doing them, Let me make this slightly longer. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This way it's different sized from its length and its width. So this here will be our height, right? We said, which I did green last time, so let's keep it consistent. This will be our height, and this will be our width. Let's write some code here off to the side that would do just this and set all these elements. So first things first, let's just say I'm going to create an integer array. I'll call it matrix. And then the way I would do this is I would make the height first. So you said the height here is 3. I would make it 3. In fact, let's create a constant variable for this. So const int height equals 3. And then I'll do the same with the width. So we'll make a const int width that is 4. And if I wanted to declare this array, all I have to do is give it the height and then give it the width. So we'll say height, and then we'll say width afterwards. Move this a little bit over so we have a tiny bit more space. When you're drawing these, it doesn't really matter which order you do the width and the height in, but I would say do row first and then column second, because that is the kind of standard way to do it. That's how the computer stores it generally, and it's how you'll see most people write it as well. And it's also the notation that we use when doing things like matrices in math, so that is probably in your best interest to do. Right, so so far what we have, we create a height and a width, and then we create this thing. So it's going to be height many tall and then width many wide. If I want to access this, you'll notice now I have 2 indices. So I need to kind of roll through height-wise and then width-wise. If I wanted to generate this, which you'll notice this order I think makes the most sense, where we go through each row and then through each column second, then we're going to need to do 2 for loops if we want to access something like this. So if I wanted to, let's just say, populate this matrix with all these numbers in order, I'm going to need to do 2 loops. And I'm going to try to do this the easy way. I'm going to create an int counter variable, which just represents how many numbers we put in it so far. And then I'm going to do 2 for loops. You can get away with doing 1 for loop, but I'm going to try to keep the math simple here, and I think this makes the most sense for accessing. So if I wanted to go through this array, I'm going to need to do 2 things. So I'm going to create an int variable. I'm just going to call this r for row and set it equal to 0. And then we'll make sure, well, r is less than height, since there will be height many rows, because each row is affected by the height, right? And then r++. And I just need a paren. And then we need a second for loop, right, to go through all the columns. So in each row, we have 4 columns. So I'm going to use C for that. C equals 0, C less than width, C++. And a funny coincidence, we have C++ in this for loop. Now I'm just going to write 2 lines of code here, since that's all we really want for our example. We just want to, count. We're just counting through all of these things and then kind of moving them to where they need to be. So if I wanted to access this in the exact order that I wrote there, all I would need to do is do a counter ++, since that's just counting how many things there are. And before I do that, I will want to use my array, which is called matrix. And then the way we access multidimensional arrays is exactly the same way that we access normal single-dimensional arrays. We just put the braces. So first is the height. So in this case, here is the row that we're going to be in. So we put the row first, which is green from what I've been doing. So R, and then we put the column. And I'm just going to say equals counter. So all this code does that I've written here is it goes through this array and counts in the exact order that I wrote down earlier. But for the sake of the example, this is how we access an array that is multi-dimensions. Row comes first, column comes second, and you can have as many of these extra braces as you want if you want something beyond a 2D array. But I think this is just a simple example on how to do it, right? So last thing to note about the 2D arrays, we'll just look at the coordinates here. If I want to access something, then just consider that it's kind of backwards from how you would normally think as far as coordinates go in math. And I mentioned this just knowing what the assignment coming up is. The y coordinate comes first before the x coordinate. So if this was an array of some kind, then we said that the rows come first before the columns, right? So it was the row number, and then the column number afterwards. Right, so we access, for instance, if we were to access R for the next move, let's just say, because there's 3 red and 3 yellow, that the red player wants to go here. Or actually, let's say here, they want to go there. Then this would be at 2, so it's row first, and then column second, so it would be 0 after that. And let's just say, for the sake of our code, we have maybe the letter R represents red or something like that, and then we would draw it on the screen like this. Now, the reason I brought this up is because it's important to note that your x and your y coordinates are in the opposite order that you normally write them for positions in math. So here, this is the y-axis, right? The ones that are in green, and then the ones that are in blue are our x-axis. My y comes first before my x, which may seem a little counterintuitive, but these are set up in such a way that it makes sense to read them, right? From the example we did earlier, you start at the top, and then you read each row, and then go down as you go. So these are designed in such a way that they make sense for reading rather than drawing pictures. But I mentioned that because we will be doing this in a future program. So I just wanted to bring it up so that everybody is on the same page. The last example I want to give here is beyond 2D arrays. Here we've gone over just 2D arrays, and these are very common. You'll see these a lot. What you might not see as often are further dimensional arrays, so of higher dimension than 2. And you can make it as high dimension as you want. You can have as many levels of indirection as you want. So here I may create something kind of ridiculous and just create something that is an int, and then I'll call it like super array, something crazy, and I could give it 10 and 9 and then 12 after that, and then 4, and then now I have a 40 array. And so this maybe becomes a little bit hard to conceptualize if you're trying to think of this in a geometric sense. So you're just strictly thinking about shapes, this becomes kind of hard. So 3-dimensional arrays is hard enough, right? It's kind of maybe a cube or like a rectangular prism-esque shape. And I think some people have a hard time wrapping their heads around it, especially when I'm asking you to look at a hypercube, which doesn't exist in 3D space. And so I think it's important to not think about these like the geometric sense. So even though I've been drawing things as a matrix, which is just, a 2x2 kind of table looking thing, then when we do higher dimensional things, I think it's more important to think of these as addresses or ways to look things up and kind of directions to where to go. So let's say I create this ridiculous array that has 10 for the first dimension, 9 for the second dimension, 12 for the third dimension, and 4 for the fourth dimension. That's its size. And then I go to access it, and I do, a 0, and then 3, and then 7, and then 1. The way I would describe this is looking through a bunch of different tables. So first things first, what I would do is maybe I would have something that is 10 long. I don't think this is actually 10 long, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And each of these is going to redirect to another kind of table. So here this is going to then redirect to its own little one that has 9 in it. Here it may make a little bit more sense if I do some colors. So let's say that this is the red dimension, this is the blue dimension, this one's the yellow, and then this last one's the green. Right, so this is our blue dimension. Each blue dimension has a red dimension in it, so for the sake of this, it's really just okay, well, my table that has 10 things in it has another thing that contains 9 things in it, and then that thing contains another thing that contains 12 in it. Again, I'm not drawing these to scale. Let's just say there's 12 in this one, and 9 in this one, and 10 in this one, and then this is the yellow dimension that we mentioned earlier, and then this one, each of these things point to 1 with like 4 in it, so I might have something like this. And this is my green dimension, which is 4 long. So I think it's important, if we're wrapping your head around these, not to think of them so much as like, oh wow, what does a 4-dimensional object look like, because that's kind of hard to think through, but rather as this being instructions of where to go when you encounter each kind of list of things. So for this first one here, if I did this where it was 0 and then 3 and then 7 and then 1, what I might do as far as my lookup is I would look in the blue list and say, okay, I'm going to go to the 0th position, which is this one, and then I'm going to look at the list that's inside there. So I go there, and now there's a list of 9 things that I can look at. And then I go to the list of 9 things and I say, okay, well, I'm going to go to the 3rd position. Let me redraw this a little bit. So this would be 0, 1, 2, 3 is right here. And then I'm going to go into the list that's inside that one. So there's another list inside that one, and it's kind of like a directory of things, right? It just tells you, okay, these are all the things you have access to, go to the next one. And then so for the last one, I would go to the position 7, 0, 1, 2, 3, 4, 5, 6, 7, which is conveniently where I already drew the other one. So I go to position 0, position 3, position 7, and then finally I end up at an array that I can actually look at. And so this one, I go to position 1, which is right here. And so this, in terms of looking things up, is where my thing is located. So try not to think of it too much, again, in geometric sense, but just, it's kind of like a roadmap of where things go. For an analogy for this, I might say, well, what if I had a city that's built like a grid, and this city, let's just say with this description, there is 10 streets that go this way, and then 9 streets that go this way, and then at each corner there's a building. So you have a building at each corner, and then the building has 12 floors, right? So it's something like this. And then in each of those there are 4 rooms, let's just say, per floor. So something like this kind of is a description. It would say, well, go to the 0th street. So I'd go to this one, and then the 3rd street down, so this one here, and then we go to the building located there. So it's at the corner of the 0th street, the 3rd street, and then we go to the 7th floor of that building, so I maybe go halfway up the building, and then I go to the 1st room in that building. So I think if this helps, an analogy to this would be like following a map. You just follow directions to where you end up. Because I think it's hard to wrap your head around these at first, and I think it's especially important if you have any interest in math and following more computer science stuff, to wrap your head around not thinking about higher dimensional problems like this in such a strict, like, space related way, and more so in a how to navigate kind of way. Anyways, these are our multidimensional arrays, and in the next video we're going to finally get to our last topic, which will be structs.